Section 4.5, question number 17. This question is asking us to solve for an x value and find the half-life of a radioactive element. So it's setting up our equation as P equals to Ft, and that's going to be the percentage of the element that remains at T years since an element was placed in a tank. In this equation, we're already given a graph, so we have some sort of guide to go off of there. It's got two main points on there. It's got our initial value, which is 0, 100, and it's got our half-life, which is going to be 10 years after the original element was placed in the tank. So our original amount is 0, 100, and our half-life is going to be 10 years. So at 10 years, we're going to have 50% of the element remaining here. Okay, I have set these up here, and the equation is asking us when the half-life will be reached. So that's already given in the equation. We know that it's going to be 10 years, so we can put that into our table there. Our x values is going to be the years or the time, since that is always our independent value. And then we're going to set up our equation as so. So we know that our a value is going to be 100, since our x is 0, and that's when we start our graph. So we're going to pretty much solve for the b value, and we have one other point on the graph, which is 1050. That is going to be the half-life, so we can introduce that into our equation so that we can solve for b. So we substitute our y by 50, and our a value is 100. 10 years is our t value, so we're going to put that over the b, and we solve for b. So we divide both sides by 100. We get 1/2 is equal to b to the power of 10. And then we go ahead and do the inverse of that power, so it's going to be 1/2 to the power of 1 over 10. Put that into our calculators, and we get b is equal to 0.9330. So now that we found our b value, we can solve for any point that we want for in the graph. This question is specifically asking us for the function of 50, meaning where is our radioactive element going to be, how much percentage is going to be left after 50 years. So we plug that into t, and I've set it up here. So we have f of t is equal to 100 times 0.9330 to the power of t. That is our equation, and the problem is asking us to find the function of 50. So once we plug all that in there, we get 100 times 0.9330 to the power of 50. We multiply that, we get 0.03125 times 100. And then we multiply that, and we get an answer of 3.13. So in 50 years, we will have about 3.13% of the radioactive element still remaining.